Iceland, A Geological History by Christy Weimer. Iceland is positioned in the North Atlantic Ocean, east of Greenland, its neighboring country. Located west of Eurasia on the east side of the North American plates. A part of the Western European time zone, Iceland is also located on the southwest coastline. 90% of Iceland's sediments are basalt because of the magma that is constantly cooling. The mid-ocean ridge at a divergent plate boundary produces the basalt. In deep waters, motions technically go unnoticed, but the eruptions still occur, creating sediments. Iceland is thought to be created by the compartment of magma that it sits on. When lava ascends and it is cooled, it slowly forms the island, and Iceland was formed about 70 million years ago. Important dates of geological transformations in Iceland. About 100 million years ago, a volcanic plume formed under Iceland, which created the most powerful hotspot in the world, the Atlantic mid-ocean ridge, which is what it was named. About 55 million years ago, Greenland, its neighboring country, strayed away from a hotspot under Iceland, resulting in endless basalt lava, which is why it is made up of 90% of that basalt. 20 to 30 million years ago, a new ocean floor was established, and distance between Greenland and Scotland was formed due to the Atlantic mid-ocean ridge, and an island was formed, which was named Iceland. 16.5 million years ago, the oldest rock was developed due to an eruption at the rift zone. The rock was located at the bottom of a burr Geological mechanisms that cause the formation of Iceland. Plate tectonics are constantly drifting, which form new crust. Iceland was developed by the accordance of the North American and Eurasian plate boundaries spreading along with the hotspot or mantle upsurge. Plate spreading also caused excessive eruptions and lava-filled rift valleys. The division of the ridge began in the north about 150 million years ago and about 90 million years ago in the south. Here are diagrams of Iceland's formation mechanisms. On the left, you will see a hotspot diagram. The orange circle indicates Iceland's hotspot, which is also Iceland's plume. On the right, it shows Iceland's mid-ocean ridge diagram. It shows the divergent plate boundaries with the spreading center, and in the middle of the spreading center is the rift zone. It also indicates the new oceanic crust forming along its spreading center. This is a diagram of Iceland's rift zone. It shows the arrows indicating which directions things are shifting and separating. Iceland's current progression. Iceland is slowly moving towards the southwest due to caused by movements in its hotspot. Both Eurasian and North American systems are shifting to the northwest across the hotspot, and tectonic plates are currently shifting east and west. Geographic complication Iceland faces because of everything shifting. Iceland is experiencing a decline in vegetation due to wind erosion. In the future, Iceland is predicted to expand, moving about 2 centimeters per year, which was about 0.8 inches a year. The east part of Iceland will continue to drift to the east as the western parts continue to shift towards the west. Brand new land is constantly conceived due to lava releasing from Earth. North American and European tectonic plates continue shifting as well. Thank you.